Hi guys, this is AS Chemistry, Organic Chemistry, and we are looking at alkanes. Question 1. The hydrocarbons A, C4H10 and B, C4H8 are both unbranched. A does not decolorize bromine. B decolorizes bromine and shows geometrical isomerism. Draw the skeletal formula of A. So A is an alkane, so A should be C4H10. So this would be CH3, CH2, CH2 and CH3 because it's supposed to be unbranched. And the skeletal formula for butane is this. The hydrocarbon A, C4H10, has a branched isomer. Suggest why unbranched A has a higher boiling point than its branched isomer. So the unbranched isomer of A has a larger exposed surface area due to which it has a greater number of London's dispersion forces present between the molecules. Thus, they require more heat in order to be overcome, resulting in a higher boiling point. So the greater the number of London's dispersion forces present, which are instantaneous dipole, induced dipole forces, so the greater would be the amount of heat required to overcome them. And once the intermolecular forces are overcome, then only would a substance boil. Question 2. Cyclohexane is a colorless liquid used in industry to produce synthetic fibers. A reaction scheme involving cyclohexane is shown. So in reaction 1, the cyclohexane has a chlorine substituted on it. And in reaction 2, we have got the chlorine and the hydrogen from another carbon atom removed and a double bond introduced. Reaction 1 involves a free radical substitution mechanism. State the essential condition required for reaction 1 to occur. So the conditions required are UV light in order to produce chloride free radicals, which would carry out the free radical substitution chain reaction mechanism. Complete the table to give details of the mechanism in reaction 1. So name of step from chlorine to chloride free radicals. This is called the initiation step. Next is the propagation step in which the cyclohexane reacts with a chloride free radical forming a cyclohexane radical, and the chloride free radical that was reacting with cyclohexane takes away one of the hydrogen atoms and forms the molecule HCl. Next, the step in which chloride or rather chlorine reacts with the cyclohexane free radical and produces chlorocyclohexane and a chloride free radical is another step in the propagation of this chain reaction mechanism. So this is propagation. Propagation. Next is the termination step. In the termination step, we've got a cyclohexane radical and a chloride free radical reacting together to form chlorocyclohexane. And this is the product upon termination of the free radical substitution chain reaction mechanism. Name the type of reaction that occurs in reaction 2. The type of reaction that occurs in reaction 2. So that is removal of one chlorine and one hydrogen from the chlorocyclohexane molecule to produce a double bond. So that is an elimination reaction because HCl has been eliminated from chlorocyclohexane to form cyclohexene. Question 3. State the name of the type of reaction that hydrocarbons undergo when being used as fuels. So fuels undergo combustion in the engines in order to be used for producing energy to run vehicles. So the type of reaction is called combustion. Write an equation for the reaction of octane as a fuel in A1. So octane is C8H18 and the number of oxygen atoms would be x plus y upon 4, which is equal to 8 plus 18 upon 4, which is equal to 12 and a half. So we have 12 and a half O2 reacting with octane, producing x moles of CO2, which is 8 CO2, and y upon 2 moles of H2O, which is 18 upon 2, which is equal to 9 moles of H2O. Question 4. There are many different types of aliphatic and aromatic hydrocarbons. Name a naturally occurring source of aliphatic and aromatic hydrocarbons and outline how different hydrocarbons are separated from this source. So, a source of different aliphatic and aromatic hydrocarbons is crude oil. And outline of the separation of hydrocarbons. So all of them have different boiling points, so they can be separated using fractional distillation as they have different boiling points. When alkanes are heated to high temperatures in the absence of air, the molecules can break into smaller molecules. Identify the type of reaction occurring. So, using temperature in order to convert a higher fraction into lower fractions, the process is known as cracking. Write an equation which describes the reaction occurring when heptane C7H16 is heated in the absence of air to form hexane, butane, and ethene only. So let's put down these reactants and products initially. So we've got C7H16 cracking to form hexane is C6H14, butane is C4H10, and ethene is C2H4. So now the number of products is greater than the number of reactants. So we need to put molar coefficient with them. So in total, we've got 7 carbon atoms in the reactant, and the product side has 6 and 4 10 and 2 12. So it's not possible to have 12 even if we multiply C7H16 by 2 or have a molar coefficient of 2. So we can have 14. So in order to make 14 carbon atoms in the product, we have to multiply the ethene by 2. So the molar coefficient of ethene is 2. And in order to balance this equation, the molar coefficient of heptane also becomes 2. So 2 moles of heptane when cracked produces 1 mole of C6H14, 1 mole of C4H10 and 2 moles of C2H4. The equation for the complete combustion of ethene is shown. So 1 mole of ethene requires 3 moles of oxygen to produce 2 moles of carbon dioxide and 2 moles of water. Calculate the volume in dm cube of carbon dioxide formed in the complete combustion of 1 gram of ethene at room temperature and pressure. So according to this equation, the molar ratio of ethene C2H4 is to carbon dioxide is 1 is to 2. So the first thing we need to do is calculate the number of moles of ethene. So the MR of ethene is C2, 12 to the 24 plus 4 is 28. And the mass of ethene is 1 gram. Therefore, the moles of ethene would be 1 upon 28, which gives us a value of 0.0357 moles. So if the moles of ethene is 0.0357, then the moles of carbon dioxide would be 2 into 0.0357, which would give us a value of 0.0714. Now, the moles of carbon dioxide have been obtained. 1 mole of any gas at RTP occupies a volume of 24 dm cube. So the volume or the volume of oxygen, not oxygen, the volume of carbon dioxide when it has 0.0714 moles present would be 0.0714 moles would give how much? So this would be 0.0714 multiplied by 24 dm cube, giving us a value of 1.7 dm cube of oxygen gas. So the answer would be volume of CO2 is 1.7 decimeter cube. The table compares the reactivity of alkanes and alkenes with chlorine. The name of the type of reaction with chlorine for alkanes would be substitution, for alkenes would be addition and substitution. Name of the type of reacting species for alkanes would be free radical and for alkenes would be electrophile and free radical. During the first stage in the substitution reaction, chlorine forms chlorine free radicals. Explain what is meant by the term free radical. So free radical is a highly reactive species having unpaired electrons. Name and explain the type of bond breaking which occurs to form chlorine free radicals. So the type of bond breaking is homolytic fission, and the explanation would be each of the Cl atom present in the covalent bond gets an equal share of the bonding electrons. So in order to better explain this, each atom gets one bonding electron to form free radicals. Name the stage of the reaction mechanism which occurs when a methane molecule reacts with a chlorine free radical. So when methane reacts with chlorine free radical, that is the start of the propagation step of the mechanism, because once the chlorine free radicals have been formed, then they can react with whatever organic compound is present along with them. So in this case it is methane, so this step is known as propagation. Complete the equation for the reaction which occurs when a methane molecule reacts with a chlorine free radical. So the chlorine free radical attacks the CH bond, breaking it homolytically, producing a methane free radical and converting itself into a molecule of HCl. So we end up with a methane free radical and HCl. Question 5. Crude oil contains a mixture of hydrocarbons together with other organic compounds which may contain nitrogen, oxygen, or sulfur in their molecules. At an oil refinery, after the fractional distillation of crude oil, a number of other processes may be used, including cracking, isomerization, and reforming. What is meant by the term cracking and why is it carried out? Cracking is the conversion of a higher fraction or size of hydrocarbon into smaller and more useful fractions or hydrocarbons that have a greater commercial or industrial demand. So, larger hydrocarbons are broken down into the smaller hydrocarbons that are more useful and more needed commercially or industrially, so that their requirements are made. This is the process of cracking. Outline briefly how the cracking of hydrocarbons would be carried out. So there are two ways. The first method would be catalytic cracking, in which we use catalysts like SiO2 or Al2O3 to bring about cracking. So this would require some heating as well, plus heat. And the other type of cracking is called thermal cracking, which would require a lot of heat. Thermal cracking. So this would require temperatures greater than or equal to 450 degrees Celsius, and it would also require high pressure to bring about the process of cracking. So catalytic cracking and thermal cracking are two different ways in which cracking of hydrocarbons are carried out. Construct a balanced equation for the formation of heptane by cracking tetradecane. So tetradecane is C14H30. So when this is cracked to produce C7H16. So if we remove 7 carbon atoms, we are left with 7 carbon atoms. So we need to form the more useful fractions. So one of the most useful fractions that we can form is octane, but octane would not be possible here because we need 8 carbon atoms and only 7 carbon atoms remain. So the second most useful product would be ethene. So we can have C2H4, and looking at the number of carbon atoms remaining, we can have 2 moles of C2H4 forming. That would use up 4 of the carbon atoms, and we would be left with C3H6. The reason we cannot have 3 moles of C2H4 produced, because if we remove C2H4 from C3H6, we will be left with CH2, and CH2 does not exist. So it is not possible to actually create more of the useful products and then a hypothetical product. So we will be having one molecule of C7H16, two molecules of ethene, and the leftover compound would be C3H6. One of the sulfur containing compounds present in crude oil is ethane thiol, C2H5SH, the sulfur containing equivalent of ethanol. Ethane thiol is toxic and is regarded as one of the smelliest compounds in existence. The boiling point of ethanol C2H5OH is higher than that of C2H5SH. Suggests a reason for this difference. So ethanol contains the OH group, which can form hydrogen bonding, the strongest intermolecular force in existence. So the amount of heat required to overcome hydrogen bonding would be greater than the amount of heat required to overcome the intermolecular forces in ethane thiol, which would be the dipole-dipole attraction. So ethanol has hydrogen bonding present between its molecules, which would require more heat to overcome. Ethane thiol has dipole dipole attractions present that do not require as much heat as hydrogen bonding. When ethane thiol is burnt in an excess of air, three oxides of different elements are formed. Construct a balance equation for this reaction. So, ethane thiol has the formula C2H5SH, which can be written as C2H6 and S. So, we can use the general combustion equation for this. The only thing we need to remember is that 1 mole of sulfur would require 1 mole of oxygen to produce SO2. So, the number of oxygen that we calculate, we add 1 to the total. So that would be x plus y upon 4, which would be equal to 2 plus 6 upon 4. 6 upon 4 is 1.5, plus 2 is 3.5. And we need to add 1 oxygen molecule for sulfur. So that gives us a total of 4.5 moles of oxygen. So the balance equation here would be C2H5SH plus 4.5 O2, producing 2 moles of CO2 and 3 moles of H2O, because X moles of CO2 and Y upon 2 moles of H2O, and 1 mole of SO2, because sulfur is part of the reactant. Two of the oxides formed cause serious environmental damage. So that should be carbon dioxide and sulfur dioxide. For each of these oxides, identify the type of pollution caused and describe one consequence of this pollution. So for CO2, it is a greenhouse gas. So it enhances greenhouse effect, and the consequence is global warming. And the other oxide is SO2, which is involved in formation of acid rain, and the consequence of acid rain is damage to limestone buildings and metal works. Also harms aquatic life, and also causes leaching of minerals from soils. These are just some of the damages that are caused by acid rain. Others include aluminum ions can dissolve in sulfuric acid and go into the water bodies, damage to forests and trees and birds and all the other lives, and corrosion of metals. A small amount of ethane thiol is added to liquefied gases such as butane that are widely used in portable cooking stove. Suggests a reason for this. So, natural gases that are used for cooking do not have any smell to them. So, if they are leaking, we would not be able to detect them. So, ethane thiol is added so that we can actually detect if there is a gas leak. So, detecting gas leaks. That is one of the most important uses of ethane thiol. Question 6. Butene CH3CH double bond CH3 is an important compound which is obtained from the cracking of hydrocarbons present in crude oil. Give two different conditions under which long chain hydrocarbons may be cracked. So the two different conditions are, one is catalytic cracking, which uses high temperature and catalysts. And example of these catalysts include SiO2 or Al2O3, but is not limited to the use of these two only. And the second way in which cracking is carried out is called thermal cracking, in which high temperatures, somewhere in the range of 450 degrees Celsius or higher, along with high pressure in combination is used to bring about cracking of hydrocarbons. Dodecane C12H26 is a long chain hydrocarbon which is present in crude oil and which can be cracked to form butene and an alkane. So we have to produce butene and an alkane along with it. So C12H26. So C12H26 when cracked would produce C4 and H8. And if we subtract 4 from 12, we end up with 8 carbon atoms. And if we subtract 8 from 26, we left with 18. So we end up with another very useful fraction that is a result of cracking, that is C8H18, which is octane, and it is what petrol is, the main component. So we end up with butene, the fraction desired in this question, and the most useful fraction desired in the industry and commercially, which is C8H18 octane. Question 7. When cyclopropane reacts with chlorine, three different compounds with the molecular formula C3H4Cl2 can be formed. Draw discrete structure of each of these three compounds. So, discrete structure of these compounds would be, one of them would be having both the chlorine atoms present on the same carbon atom, which would be Cl here and Cl here. Another would be having the two chlorine atoms on two adjacent carbon atoms. So that would be one chlorine here and one chlorine here. This would be the second possible compound that can form. And a third one would have the chlorine atoms on two different carbon atoms, but their positions would be different. In the one in the center, the chlorines were present both below the carbon atoms. In one structure, we can have one chlorine atom above and one chlorine atom below on the other carbon atom, because these carbon atoms are joined together in a cyclic ring and their positions cannot be changed because there is restricted rotation because of the cycle cyclic compound. So the one pointing upwards will remain upwards, the one pointing downwards will remain downwards. They cannot switch position and point towards the same side or be positioned in the same plane. So in this way, we have three different structures containing two chlorine atoms of cyclopropane. Question 8. Propane and butane are components of liquefied petroleum gas, which is widely used as a fuel for domestic cooking and heating. To which class of compounds do these two hydrocarbons belong? So C3H8 and C4H10 are both alkanes. Write a balanced equation for the complete combustion of butane. So C4H10 plus x plus y upon 4, which would be 4 plus 10 upon 4. 10 upon 4 is 2.5, and 4 plus 2.5 is 6.5. So this will give us 6.5 moles of O2 producing x moles of CO2, which is 4 moles of CO2, and y upon 2 moles of H2O, which is 10 upon 2, which is equal to 5 moles of H2O. So this is the complete balanced equation for the combustion of butane. When propane or butane is used in cooking, the saucepan may become covered by a solid black deposit. What is the chemical name for this black solid? So it is carbon that is being deposited onto the saucepan, also called soot, but the chemical name would be carbon. The general name is soot. Write a balanced equation for its formation from butane. So if we have formation of soot from butane, so C4H10 would burn in oxygen to produce, if we convert all of the carbon into soot, so that would be 4 moles of carbon, and we would have 5 moles of H2O being produced. So in order to balance the equation, we require 5 atoms of oxygen, which is equal to 2.5 moles of oxygen gas. So this is the equation for the formation of carbon when it is burnt in the form of butane. The boiling points of methane, ethane, propane, and butane are given below. So the boiling points are increasing. Suggest an explanation for the increase in the boiling points from methane to butane. So, as the length of the carbon chain increases, the number of electrons present increases, resulting in greater London's dispersion forces, which require more heat in order to be overcome when boiling. So the boiling point will definitely increase because more heat energy would be required to overcome the greater London's dispersion forces present due to increase in the number of electrons because the carbon chain is increasing and the MR is increasing. The isomer of butane 2-methyl propane has a boiling point of 261 Kelvin. Suggest an explanation for the difference between this value and that for butane in the table above, which is 273. So the isomer which is branched has a lower boiling point. It means that it has a lower number of London, yeah, or smaller number of London's dispersion forces present. So that is because of the branching. So straight chained compounds can pack more closely together, having a larger exposed surface area compared to branched compounds. This results in a greater number of London's dispersion forces being present between their molecules, leading to a greater boiling point. And this is because the greater the number of London's dispersion forces present, the greater the amount of energy in the form of heat would be required to overcome them in order for the straight chain compound to boil as compared to the branch compound, because the number of London dispersion forces would be lesser, so lesser amount of heat compared to the straight chain compound would be required in order for the branch compound to boil. Question 9. Petrol and diesel fuel are both used in internal combustion engines. Petrol may be regarded as having the formula C9H20 and diesel fuel as having the formula C14H30. To which class of compounds do these two hydrocarbons belong? So they belong to the class of compounds called alkanes. Write a balanced equation for the complete combustion of petrol. So petrol is C9H20 in this question. So C9H20 would require X plus Y upon 4 moles of oxygen, which is 9 plus 20 upon 4. So 20 upon 4 is 5 and 9 plus 5 is 14. So we need 14 moles of O2 to produce X moles of CO2, which is 9 moles of CO2, and Y upon 2 moles of H2O, which is 10 moles of H2O. So this is the balanced equation for the complete combustion of C9H20 or petrol. When petrol or diesel fuel are used in internal combustion engines, several different products of the incomplete combustion of the fuel may be formed. Name two of these products that do not contain hydrogen. So, name of these products. So, one of them would be carbon monoxide because CO does not contain any carbon atoms, and we will have carbon being deposited in the engine, which is also called soot. So, carbon also will not have any hydrogen present in it. Choose one of these and state a hazard it causes. So, the product would be carbon monoxide, and the hazard that it causes is it binds to hemoglobin and prevents the uptake of oxygen in the blood of humans. So, if humans are exposed to a large quantity of carbon monoxide, they would die by suffocation because carbon monoxide binds to hemoglobins with a 200 times more affinity than oxygen. That means if the carbon dioxide molecule is attached to hemoglobin, it cannot be replaced by an oxygen molecule ever. Write a balanced equation for the formation of one of the products in one from diesel fuel. So diesel is C14H30. So C14H30 when burned in oxygen. So we can have production of soot, which would be easier to make. So that would be 14 moles of soot or carbon, and we have 30 atoms of hydrogen. So we would end up with 15 moles of H2O. And in order to balance the number of moles of oxygen, so we need 15 atoms, which is equal to 7.5 moles of oxygen gas. So diesel would burn in 7.5 moles of oxygen, which is a limited supply, to produce 14 moles of carbon and 15 moles of water. Question 10. The reaction of ethane with bromine forms a mixture of products. State the essential conditions for this reaction to occur. So the reaction between an alkane and a halogen requires UV light. Give the full name of the mechanism for this reaction. So this is called a free radical substitution reaction mechanism. Give the equation for a termination step that could occur producing a hydrocarbon. So we have ethane. Ethane contains two carbon atoms. So a termination step in which a hydrocarbon is produced would be 2 moles of ethane free radicals, which would be C2H5, reacting together to form a hydrocarbon of formula C4H10, which is butane. Give the equation for one propagation step involved in the formation of dibromoethane from bromoethane during this reaction. So we have the formation of dibromoethane. So the radical would contain C2H4 and one B are already present, and this would attack a bromine molecule, producing a dibromoethane molecule C2H4Br2 and producing a bromine free radical in the process. Crude oil is processed to give a wide variety of hydrocarbons. Give the names of one physical process and one chemical process carried out during the processing of crude oil. So, a physical process that is carried out is called fractional distillation to separate the different fractions. And a chemical process that is carried out is to convert the larger hydrocarbons into the smaller, more useful ones. So, that is called cracking. Alkanes and alkenes can both be obtained from crude oil. Explain why alkanes are unreactive. They have carbon and hydrogen atoms present in covalent bonds. Carbon and hydrogen have very little difference in electronegativities, because of which they are non-polar and hence unreactive. We can also include here that the carbon-carbon bonds and the carbon-hydrogen bonds have high bond energies. That means they are stronger. So it is not easy to break those bonds. That is another reason why alkanes are unreactive. Use a series of equations to describe the mechanism of the reaction of ethane with chlorine to form chloroethane. Name the steps in this reaction. So this is the free radical substitution chain reaction mechanism. The start of this mechanism involves a step called initiation, in which we have a chlorine molecule subjected to UV light, and this results in the formation of two chlorine free radicals or chloride free radicals. This is the initiation step. Next, we would have propagation step or other propagation steps, in which we have an ethane molecule C2H6 being attacked by a chloride free radical, producing C2H5 free radical and a molecule of HCl. The C2H5 free radical would attack a molecule of chlorine, producing C2H5Cl, which is chloroethane, and producing a chloride free radical in the same process. So in these two propagation steps, we have produced chloroethane, which was the requirement of this question. So this is the propagation step. The next step in this mechanism is called the termination step, and these termination steps can be various. One of them could be two chlorine free radicals would combine together to reform chlorine, or we could have a C2H5 free radical combining with a chlorine free radical, producing C2H5Cl, which is chloroethane again. So these are the three steps in the free radical substitution chain reaction mechanism that alkanes undergo when they react with halogens in the presence of UV light. Write an equation to show how butane could be produced as a byproduct of this reaction. So production of butane would require two C2H5 free radicals colliding together and forming C4H10 as a byproduct in one of the termination steps. Question 12. Ethane reacts with chlorine to form chloroethane. State the conditions needed for this reaction to occur. So UV light is required in order for this free radical substitution chain reaction mechanism to occur. Use a series of equations to describe the mechanism of this reaction, including the name of each stage and an indication of how butane can be produced as a minor byproduct. So this step would be the termination step for this chain reaction mechanism. So here we can start off with the initiation step, which includes a molecule of chlorine subjected to ultraviolet light and being converted into two chloride free radicals. And availability of the chloride free radicals begins the propagation step. And the propagation step would involve C2H6 colliding with a chloride free radical, producing C2H5 free radical and a molecule of HCl. In the next step, we have got C2H5 radical colliding with a molecule of chlorine, breaking the bond, producing C2H5Cl, which is chloroethane, and a chloride free radical. So these are the two steps in the propagation part of the chain reaction in which we end up with the formation of C2H5Cl. And in the termination step, the question requires us to produce a molecule of butane as a byproduct. So that would require two C2H5 free radicals colliding with each other during the termination step to produce a molecule of C4H10, which is butane, as a byproduct of the free radical chain reaction substitution. Question 13. Heptane C7H16 is an undesirable component of petrol as it burns explosively, causing knocking in an engine. The reaction of heptane with chlorine in the presence of UV light produces a wide variety of products. Formation of the monochloroheptanes can be represented by the following equation. C7H16 plus Cl2 gives C7H15Cl plus HCl. Name the mechanism of the reaction between heptane and chlorine in the presence of UV light. So this is called the free radical substitution reaction mechanism. Describe this mechanism using suitable equations and including the names of each stage in the process. So we need to produce a monochloroheptane. So that would require the initiation step as being chlorine gas being subjected to UV light producing chloride free radicals. In the propagation step, C7H16 is attacked by a chloride free radical producing C7H15 free radical and a molecule of HCl. The C7H16 rather C7H15 free radical attacks a molecule of chlorine producing C7H15Cl, which is the monochloroheptane, and also produces a chloride free radical in the same reaction process. So here we have C17 C7H15Cl being produced. So we do not need to show other propagation steps. So now we move on to the termination step. So the termination step would include either two chloride free radicals colliding with each other to produce Cl2 or The termination step may include a C7H15 free radical colliding with a chloride free radical producing T7H15Cl monochloroheptane, or we can also have two C7H15 free radicals colliding together and forming a large molecule of C14H30. So all of these steps can be possible in the termination of the free radical substitution reaction.